Hello friend, I myself Sujit Jha, physics mentor, motivational speaker and author. In this video we discuss about question number 26 of IRODOV. A point moves in the plane xy according to the law x equals to a sin omega t, y equal to a into 1 minus cos omega t, where a and omega are positive constants. Find the distance s traversed by the point during the time tau, the angle between the point's velocity and acceleration vector. In this problem, author want to say that a particle move in xy plane, such x component of displacement and y component of displacement is given by x equals to a sin omega t and y equals to a into 1 minus cos omega t. This is the x component of displacement and this is the y component of displacement. We have to find the distance covered by the particle in tau time. Okay, first of all we have to find instantaneous speed. What is the speed of the particle in this case, such that their displacement component of displacement is given by a sin omega t and component of displacement along y axis is given by a into 1 minus cos omega t. Okay, so first of all differentiate this equation with respect to time. It means velocity of particle along x axis is given by d by dt a sin omega t. This is a omega cos omega t. Now differentiate this equation. Velocity along y axis is given by d by dt a into 1 minus cos omega t. Okay, a is constant, so differentiation of this equation is given by a omega sin omega t. This is the component of velocity along x axis and this is the component of velocity along y axis. Okay, so instantaneous speed or instantaneous velocity of the particle is given by root under vx square plus vy square. Okay, what is the value of Vx? Vx is equals to a omega cos omega t. So square of this equation is a squared omega squared cos squared omega t plus Vy squared. It means a squared omega squared sin squared omega t. A squared omega squared sin squared omega t. A omega should be common. So a omega root under sin squared omega t plus cos squared omega t. This is equals to 1. So velocity or speed of the particle is given by a omega. This is the instantaneous velocity or instantaneous speed. Now velocity ds by dt, this is the rate of change in distance with respect to time. Instantaneous speed of the particle is given by this equation ds by dt. Okay, so this is equals to a omega. Now ds equals to a omega dt. Now integrate both sides. So integration of ds equals to a omega is constant and integration of dt for 0 to tau time and 0 to s integration for distance. Okay, so s is equals to s0 to s equals to a omega, integration of dt is t 0 to tau. So s equals to a omega tau. This is the distance covered by the particle during tau time interval. Now we have to find the angle between velocity vector and acceleration vector. So from this equation Vx is equals to a omega cos omega t and Vy is equals to a omega sin omega t. So velocity vector is given by a omega is common cos omega t I plus sin omega t j. This is the velocity vector. Differentiation of this equation is acceleration. So acceleration is given by dv by dt. Differentiate this equation with respect to time. A omega is constant, d by dt cos omega t I plus sin omega t j. A omega, differentiation of cos omega t is minus sin omega t into omega and differentiation of sin omega t is cos omega t into omega. Okay, so omega into minus sin omega t I and omega cos omega t j. So acceleration is equals to a omega square minus sin omega t I cos omega t j. This is the acceleration vector and this is the velocity vector. Assume acceleration, symbol of acceleration is w. Okay, w is the symbol of acceleration. Now we have to find angle between velocity vector and acceleration vector. Dot product of two vector a dot b equals to ab cos theta. So find out the dot product of velocity vector and acceleration vector. Okay, I dot I 1, j dot j 1. Okay, so velocity vector and acceleration vector. Dot product of velocity vector and acceleration vector is equals to a omega and a omega square omega cube into sin omega ti cos omega ti. Dot product of this quantity is equals to minus sin omega t into cos omega t plus product of dot product of j dot j equals to 1. So sin omega t into cos omega t. Okay, this is cancel out and dot product of velocity vector and acceleration vector is equals to 0. If dot product of two vector is equals to 0, then both vectors are perpendicular to each other. So angle between velocity vector and acceleration vector is equals to 90 degree. So we say that velocity vector should be perpendicular to acceleration vector. Theta equals to pi by 2. Theta be the angle between velocity vector and acceleration vector. This is the answer of second part of this question. Thank you.